Hey, welcome back, Algebra 2 Trig. We're going to continue with 10.5 polar coordinates. Today we're going to focus on conversion. So our essential question is, how do I convert coordinates from polar to rectangular and vice versa? What I have drawn right here is basically what we've been sketching. So a certain point within space, and we've been using rectangular coordinates up to now, using like x, y, and we would go a certain amount of distance. But just like you focused on over the weekend, we are now using polar coordinates using some radius value and a theta value. We are going to be using a bit of trig today, so we do want to remember these relationships, especially tan theta. So you got to remember that tan theta is going to be equal to y over x. Right? It's going to be essential for our conversions, and that's going to be noted right here in coordinate conversion. So go ahead and copy down this highlighted text. Pause if you need to, but I'm going to go ahead and now jump in to example 1, where we're going to convert a polar coordinate to rectangular. Okay, so the only difference between a polar coordinate is that a polar coordinate is represented using r and theta, and a rectangular coordinate is one that's represented using x, y, pretty much what you've learned up to Algebra 2 Trig. Okay, so these are interchangeable using a different variety of formulas and equations, like the ones that you just copied down. So what we're going to do is convert to pi. Now what I'm about to do is show basically all of the work. You don't need to do this every single time, but it pretty much helps me organize the information. So here I see that r is equal to 2, theta is equal to pi. And what I need to do is convert these into x and y coordinates. Okay? So my goal is to get it in some xy form. And the way I'm going to do that is using the idea that x is equal to r cosine theta and y is equal to r sine theta. And that relationship is actually gained from over here, where we multiply r to both sides in order to solve for y and x. So if I multiplied r to both sides here, I get r sine theta equals y, and that's how I have this part right here. Okay? So my goal really is not going to be xy, instead it's now going to be r cosine theta and r sine theta. I substitute in these values, so the 2 and the pi, 2 cosine pi and 2 sine pi. With that, we go ahead and simplify. So cosine of pi is going to be -1, so my answer here will be -2. Sine of pi is going to be 0, so 2 times 0 is 0. So the rectangular coordinate for 2 pi is just going to be -2, 0. Okay? And that pretty much matches if I were to graph this point and this polar coordinate, they would end up in the same exact spot. Right? So that's converting one way. Let's go ahead and convert in the reverse direction. So convert a rectangular coordinate to polar. So in this one, I'm going to be converting something that looks like this guy, -2, 0, into something that looks like 2 pi. So here I'm going to convert -3, 1. So once again, I'm also going to organize my information. Here I have x is equal to -3, y is equal to 1. In this case, because I am provided with an x and a y, let me clear this up real quick. Because I'm provided with -3 and 1 as my x, y values, I'm going to have to use one of my trig relationships. And that's why we fall back to tan theta. Tan theta is equal to y over x. So we're going to use that relationship in order to help us find both r and theta. So tan theta is equal to y over x. Let's go ahead and substitute in. So tan theta is now equal to 1 over negative square root of 3. Okay. So with that, if you remember your unit circle, then you can go ahead and skip ahead. For me, I'm going to go ahead and sketch out the triangle real quick. My x value is negative radical 3, so just a little past 1. And then so there's my triangle. And the angle measurement that would be in here would be 5 pi over 6. Because remember, we are talking about the unit circle, and this would be our starting point, where we would have to go all the way over to the other side. Okay? So this whole angle is 5 pi over 6, which means I know that my theta is 5 pi over 6. Again, if you were able to figure that out using your unit circle, feel free. If you need to refer back to triangles, do that as well. Okay? Now, in order to get the r value, you can either use special right triangle relationships and just figure this out, but in some cases you're actually going to have to calculate it out using one of the relationships provided. So here it says that r squared is equal to x squared plus y squared. In order to get r, well, let's go and show it. R squared is equal to x squared plus y squared. In order to get r by itself, I got to take the square root of both sides, which means r is going to be equal to the square root of x squared plus y squared. We have all that information provided, so r is equal to negative radical 3 squared plus 1 squared. This simplifies out to 3 plus 1. Square root of 4 gives us 2. If you knew your special right triangles, we already knew that this radius, or this hypotenuse in this case, was supposed to be 2. So that kind of confirms it for us. Okay? So we have our r value, r is 2. We have our theta, it's 5 pi over 6. Our polar coordinate is 2, 5 pi over 6. Okay? So that's pretty much it for the notes. That's what you guys are going to be working on tomorrow. If you have any questions, make sure to write it down. Otherwise, see you tomorrow.